All right, so the last section for chapter 3 is called the HL postulate. HL stands for hypotenuse leg. So the postulate is as follows. If there exists a correspondence between the vertices of two right triangles, I'm going to underline right triangles, such that the hypotenuse and the leg of one triangle are congruent to the hypotenuse and the leg of the other triangle, then the triangles are congruent to each other. So far we have done side, side, side. That is 3 things in order to prove these triangles congruent. We have done side, angle, side. That is 3 things to prove these triangles congruent. We have done angle, side, angle. 3 things to prove the triangles congruent. And the last thing is called hypotenuse leg. So it's like, wait a minute. Why is there only 2 things? There's not. Don't let that fool you. You have to state that there is a right triangle in each of these triangles in order to prove that they're congruent using hypotenuse leg. A hypotenuse is the side that is across from the right angle. So again, you need a right angle to state that the hypotenuse is congruent. And then you also need one of the legs. So here's the tricky part, guys. When you look at this, sometimes it's like, well, wait a minute. Isn't this angle, side, side, angle, side? Why wouldn't this be side, angle, side? Because the angle is not touching both of the sides. The angle would have to be over here in order for it to be side, angle, side, and it's not. Okay, the angle's over there, and there's no such thing as side, side, angle, or angle, side, side, because that spells a bad word. So this has to be, it can't be side, side, side. It can't be side, angle, side. It can't be angle, side, angle. So now there's the last method that you can use. And again, you're looking for right angles, and then you're looking for the hypotenuse to be congruent and the leg to be congruent. Okay, so again, that's still 3 things. You still have to state that the triangles are right. And then if a triangle has a right angle, you know it's a right triangle. And then you have to have the hypotenuse congruent and the leg congruent. So I'm going to show you what one of those proofs would look like, and then we're going to do another example in class. So I'm going to write my statements and my reasons that were given. Okay, we are given that BC is perpendicular to AC, given. Okay, so BC right here is perpendicular to AC right here. And so whenever we have 2 segments that are perpendicular, segments are perpendicular, it creates a right angle. So I'm going to put that down. Angle C is right. Okay. If segments are perpendicular, then they intersect to form right angles. Okay, then they intersect to form right angles. My next given says that BD is perpendicular to AD, and that's given. So BD is perpendicular to AD, and again, I'm going to mark my right angle. Therefore, angle D is right. And that is for the same reasoning as number 2. If segments are perpendicular, then they intersect to form a right angle. My next given says that AC is congruent to AD. AC is congruent to AD. And that is given. And now we're going to take a look at these triangles. So again, you're going to have to analyze this. It's like, well, wait a minute. I know that this angle is congruent to this angle. I know this side is congruent to this side. And then again, we have this reflexive side that I can pull off. This is not angle, side, angle. The angle is not touching both of the sides. So you might have to erase it and try again, right? This perseverance that we have. So we know that this reflexive side is here. And we know that this is the side across from my right angle, which is also known as my hypotenuse. And then we have a leg here and a leg here. So first we have to state that AB is congruent to AB, and that is any segment is congruent to itself. That is the reflexive property, This is also a hypotenuse. The orange ones are legs. And again, my third piece of information, I have to have right triangles, which I do. So I have enough information now to say that triangle ABC is congruent to triangle ABD, and that is by hypotenuse leg. In step 6 and 5, and I said that they were right angles in step 4 and 2. Okay, so it's hypotenuse leg in 6 and 5, and I stated that they were right in step 4 and 2. Why do I care that they're congruent? Again, I'm trying to prove that CAD, this angle, is getting bisected. In order for this angle to be bisected, this piece has to be congruent to that piece. So that's the next piece of information I'm pulling out. Angle CAB has to be congruent to angle DAB. And that's because if triangles are congruent, then their corresponding parts are also congruent. So immediately after we pull the triangles out, you're looking for the parts that you want congruent. So those are the parts that we pull out that we want congruent to each other. And why do I care that those parts are congruent? Because now I know that AB bisects angle CAD. If an angle is cut into two congruent angles, then it was bisected. So that is the converse of the definition of bisect. Okay, so an angle that was bisected has two congruent angles. So if an angle has two congruent angles, then it was bisected. So you can see I'm using hypotenuse leg. I stated that there's a right angle in the blue triangle. There's a right angle in the purple triangle. I stated the hypotenuse, and I also stated the leg. So we'll do one more example of this in class.